The very last section of this chapter then is going to be 6.6, and it's tied into what we were doing last time with the linear inequalities where you need a shade, but now it's going to be systems. So it's solving systems. So you'll have two, maybe more, typically two, solving systems of linear inequalities. And really what a lot of it is you're just doing what we did yesterday, the graphing an inequality. You're doing that twice. And then the part that's shaded both times, you just shade extra dark. So it's really not that much more difficult, I don't think, than yesterday, but maybe we'll find out it is as we go through and do some stuff. With this, I'm going to start out by writing graphing and then write down 2 steps. You're welcome to do that or not. For me, this is something that really helps me if I can just go back, look at my notes, and all right, like a lemming blindly, what do I do for step number 1? So the first thing is you just graph each one. So graph each inequality. And when we graph an inequality, we always shade one side. So I'm going to just say, and lightly shade. Because we're going to have to do, like, our final answer is going to be a combination of those 2 graphs together, I wouldn't do like a really nice job shading, just enough to be like, oh, it's this side of the line. And then once you have done that for both of those, you shade much darker the part that was shaded every time. So shade darker, because that'll be your actual answer. The part that was shaded if you only have 2 of the inequalities, you could say the part that was shaded twice. I'm trying to kind of set up that you could have 3 or more. Typically we won't, but part that was shaded. That's why I said every time. Apparently I can't talk and say the word shaded. Shaded every time. You see me brush my teeth and walk. All right. Example 1. So example 1. Example 1. I'm going to say y is less than 3x plus 4. And y is greater than or equal to negative 2x plus 1. So that's going to be my system of inequalities. And it's going to be kind of obnoxious. I'm going to try to jump back and forth between 2 pages just so I don't run out of room. But I'll come back to that in just a second. So the first one, y is less than 3x plus 4. We know what point's on the line, boundary line? So the y-intercept is positive 4, right? And 3 is the slope. Solid line or dashed line? Dash, because it's not a or equal to, it's just less than. So all right, so I do for that top one, said the y-intercept was 4, then a slope of 3, so up 3 over 1, up 3 over 1, down 3, left 1, down 3, left 1. And so we have our shaded boundary line. Wow, hopefully yours will look better than that. I'm typically better when I'm not on an iPad. So y-intercept of 4, slope of 3, although maybe for you, you're just kind of sketching it. But now we need to figure out, okay, does the origin or does some point work for that one? So I'm going to take and put the origin in there because we didn't go through the origin. So if I put a 0 there and a 0 there, I end up with 0 is less than 0 plus 4. Is 0 less than 4? Yep. Yeah. So then from there we know we need to shade the side that has the origin. So I'm going to take and just kind of, I'm just going to do something like that, just kind of like so I can keep in my head that I'm shading to the right. Some people, they don't shade anything, and then they just try to keep it all straight. I found they often make mistakes. All right, second one now. If we're going to take this second equation here, I'll do that one in brown. So y-intercept of 1, slope of negative 2, and our boundary line is solid or dashed? Solid, because it's the or equal to. All right, so y-intercept was 1, so right there. Slope of negative 2, so down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. Or you could go up 2, left 1. And I can try to do a solid line through that. And now we want to take and put some point in there to figure out, does that point work? We don't go through the origin, so I'm going to do the origin again, just because it makes the math super easy. So if I put a 0 in for x, a 0 in for y, my negative 2x just cancels out, becomes 0. I get a 0 is greater than or equal to 1. True or false? False. So we know the origin doesn't work for this one. So now we need to shade this side here. Everybody still tracking with me? So final answer then, I'll just do mine in black, is going to be the part that's shaded both of those times. So it would be this part here of those two. Some people will go through and they'll actually kind of erase the part that doesn't fit for their other shading. And you could do that, but you don't have to. Just make it real clear what part is your final answer. Is that fair?
So where both are shaded?
Yep, where both are shaded. If we had added, I wouldn't mess up your notes with this, but say we had added another one to it, that x has to be less than 5. So then you'd have a 1, 2, 3, 4, 5. So if it's x is less than or equal to 5, that's going to be a solid line like this. And then you'd also, so then your final answer would just be what's inside like those 3. So that's why I said like what's shaded like all the time, because then you'd have to get rid of all of this. It would just be that inner triangle thing that's shaded. Is that fair? But I wouldn't worry about that at this point. So second example is going to be a bit of a story problem. It's going to have kind of one of those like limited domains, we'll say. So Ed, somewhat because his name is short, he has a job mowing and raking. So job, mowing, and raking. So Ed is going to pay for his college. Okay, in 1 week, so I'm going to try to abbreviate my question here, but 1 week he has a maximum of 9 mowing jobs, or a max of 7 raking jobs. So if he just mows, he can get 9 total. If he just rakes, he can get 7 total. And we'll say Ed charges $20 to mow, and $10 to rake. And we'll say he earns more than $125. So now the question would say from there, like, show all the possible combinations. So what's all the possible combinations of mowing lawns and raking lawns? And we're going to just shade in an area. Technically, we probably should put a dot for each possible combination in that area, because he's probably not going to get paid if he mows like a third of a lawn or rakes half a lawn or something like that. But we'll just kind of assume we're going to shade in the area. All right, so we need to come up with some equations. The easiest might be this one here. Ed charges $20 to mow a lawn and $10 to rake. He earns more than $125. How would we take and change that into an inequality, I suppose, not an equation? Maybe I should back up and say, what are my variables? That's probably a good place to start. So our variables will be, variables like x and y, but what letters do you want to use? Yep, m and r. So m would be like the number of lawns he mows, r is the number he rakes. Fair enough? So we want to somehow take those numbers and combine them with m's and r's and do stuff. All right. So good start. Because 20m, if m is the number of lawns he mows, if he gets $20 for each lawn he mows, if he mows 1 lawn he gets $20, 2 lawns he gets 40, 20 times 2. So that makes sense. What do I put between those two? Plus. Not equals. I'd like your... Perfect. Greater than or equal to. Because we said that he makes more than or he makes at least $125. Good job. Good job. And does that make sense to everybody? So maybe you couldn't do it on your own, but with a little practice, hopefully you get to that point that you could. Now, if I jump up a little bit, if he has maximum of 9 lawns that he can mow, how would you write that one? If he just mows, no raking, he could do up to 9 lawns. How would you write that? So something with an M because it's a mowing, and something with a 9. It doesn't have to do with pay though, so you don't want to do 20M. M is less than or equal to 9. So if he just mows, he gets up to 9 lawns. So he could have maybe just mowed 7, could have mowed 6, could have mowed 8, could have mowed 9, but can't mow 10 or 9.5 or something. Right. So that I thought would probably be the toughest one. Maximum of 7 lawns if he just rakes, that would be perfect. R is less than or equal to 7. R is less than or equal to 7. How you feel about that? Good? Now here's the other thing. When you think about possible combinations for M and R, what numbers couldn't you have for number of lawns mowed? 10. Well, you couldn't have 10 because that's too big.
Negative.
Couldn't have negative. That's what I'm really going at. That when we graph this, our graph really needs to be just quadrant 1, because you're not going to have a negative number of lawns raked or a negative number of lawns mowed. If you do, you're losing money. That'd be a bummer. So, all right. Now for this, I'm going to jump back here, and because we did M first, and usually our equations have X before Y, can I convince you, let's just put M on the X-axis, so mowing on the X-axis, raking on the Y? And you could switch that around unless it tells you have to do a certain thing, but just that way they're in order. So I'm going to put down here, I'm going to say this is like the mowing, or M. Over on the Y-axis, I have raking, mowing and raking. And I'm going to figure out a little bit more about my equations before I actually start putting lines and whatnot on the graph. We know M has to go up to at least 9, right? From this Brown equation, our mowing has to go up to at least 9. Our raking has to go up to at least 7. And this one here, though, we need to figure out my X's and Y's. Is that going to be bigger than 9, bigger than 7, less than that? So let's figure out how to graph that one. How would we graph that line there? Standard form, we find intercepts, right? So if I put a 0 in for X, what's my Y going to be? Perfect, 12.5. For people that didn't see that there, what we're doing is we're taking the 0, putting it in here for M. So then you agree this whole part there just becomes a 0? Because 20 times 0 is 0. So we're left with that positive 10R, kind of treat it like an equal, so we get the 12.5. We okay on the first point?
Yeah.
Then our second point, we want to do the same thing, but we put a 0 in for Y, which then makes this drop out. So we get a really close? 6.25. But what we're doing is once that 10R drops out, we're doing 125 divided by 20. And we get the 6.25. So we now know that my Y-axis has to go up to at least 12.5. My X-axis has to go up to at least the 9, because we have this one right there for the X-axis. All right, so my Y-axis goes up to 13. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13. I guess I'll just make each one be 1. So if that's going to be a 0, 1, 2, 3, 4, so that's a 5, 6, 7, 8, 9, 10. So 10. That a 14. My X-axis, I need to jump back. X-axis has to go up to at least 9. So I'll maybe go up by 2's here. So 2, 4, 6, 8, 10. So I have 1, 2, 3, 4. So I could label some, but you don't have to go every other if you were doing that. I'm just I'm trying to spread it out a bit. All right. Now, if we were to go back and graph my green line, that's where we go through and we have the y-intercept of 12.5, x-intercept of 6.25. So 12.5 is right there. 4, 5, 6.25 is going to be right about there. And solid boundary line, dash boundary line, solid because it's or equal to. You could, if you wanted to, extend that line like down below the x-axis and up to the left of the y-axis, but you don't have to because We can't have numbers over there. And then for this, if we would put the origin in and check it, we'd find we need to shade here. I'm just going to kind of skip ahead a little bit to save time. So yes, these combinations are, ooh. No, I should have been on the ball. If I would go through and put in, shade lightly. Well, okay, if I'd put in my zeros, after going off of other people not showing their work, 0 is greater than 125. No. So I need to shade the outside of that. So I should have shaded over here for this one. And some days it feels like that. Now, my next one's my Brown equation here. My m is less than or equal to 9. M was like my x value. So we know then it's less than or equal to. So it's going to be a solid boundary line through that 9. So something like that. You could go down below the x-axis if you wanted to. If I put the origin in, when I put the origin in for m, I just get a 0 for my x value. Is 0 less than or equal to 9? Yep. So then my brown is going to be shaded this way. And then the very last one, my blue line there, r is less than or equal to 7. R is like my y value. So if you had a y is less than or equal to 7, it'd be a horizontal line. So we need to be horizontal there. So I'm at 7. Then, so if I put a 0 in here, I'm going to check like a height of 0. 0 is less than or equal to 7. Yep. So that's true. So now I know I shade down to the origin. So I shade this way for that. So the final answer is just what is shaded every time. Agreed? So the final answer then is going to be what's below the blue line, to the left of the brown line, but to the right of the green line. So this area here is going to be all the possible combinations of mowing and raking that he could fit in a week, and that would get him at least that much money. Now technically, and then I'll jump to you guys, technically what I should be doing is I should be putting a dot right here, saying, actually no, that's half a lawn. That doesn't work. I should be taking and putting a dot right here and saying he could have mowed, or there, he could have mowed 7 lawns and raked 0. And then you could go up 1, and he could have mowed 7 lawns and raked 1. And so you could get different combinations that way. But technically your answer then would be like all of those points in there. But we're not going to focus on that quite yet. So 3 special cases. So special cases with parallel lines. And if you're feeling a little overwhelmed, I don't think this is going to be too bad. I think you'll be okay. I'm just going to draw parallel lines, attempt to draw parallel lines. We'll pretend those are parallel. If in doing these inequalities, if that first one I needed to shade up, and the second one I need to shade down, if we're looking at the system of those two together, what do we have as far as solutions go? Nothing. Nothing is shaded twice. Nothing shaded for both of the inequalities. So one like that, we have no solutions. So that's kind of the first type of special case. You have no solutions because nothing is shaded twice. Okay, move on to the second one. Okay, the second one is going to be what the book typically gives you if they have parallel lines. It seems to me at least that typically you get something like, I'll maybe do 2 colors. So one parallel line and we're shading this way. The second parallel line, so I'll do mine in blue. And you could even have like a dashed boundary line if you wanted to. But with that blue one now we're shaded this way. So this is kind of the more common what people give you. The answer then is going to be what? The stuff in the middle. Because that stuff in the middle is shaded twice. So it's just going to be the stuff between the 2 lines, something like that. So if you wanted to, you could say something like the solution is in the middle.
Wait, why is that special case?
The special cases are probably more just that the lines are parallel. So you don't have like a little wedge shape. This one here, of the special cases, is definitely the least special. Don't tell it I said that. It'll hurt its self-esteem. All right, number 3. The very last one is it's possible that you would have both lines kind of shaded in that same direction. So if I have a green line shaded that way, I have a blue line that's parallel to it, and I'm also shading down. Now the actual solution is going to be all the stuff that's down to the right of the second one. It's the same answer for the system as what you have for that blue line, because whatever's shaded by the blue line was also shaded by the green. So the solution then would just be that side. So the solution, and I suppose the solution would also include that blue boundary line as well, because that blue boundary line was included in the green shading and in the blue solution as well.